All right, so welcome back. And this is the second session of the Edgar's Guide to Python and Neuroanalysis. So I recognize most of you. There's perhaps like one or two person coming in new. So hi. So just like last time, we're going to pretty much spend our time inside this Jupyter Lab environment. So what you ought to do is just go again to jupyter.edgars.guide. And if you haven't done so already, what I need is a GitHub username. So on the Slack channel, just message to me your GitHub username so I can add you to the list. I think it's him. Yeah. But aside from that, today we'll start session 2. So we'll start by looking at the notebook that says 02, deeper into Python, which is exactly what we're going to do today. We're going to dive deeper into the Python. So last time we started with the Python as a language. I gave you a bit of spiel why Python might be nice and why you might care to learn about it. And we started by looking at, okay, how to use it as a calculator, how to define variables to make it do something richer. And then we looked into different ways like by which Python store different data types. We looked at the simple data types like integers and floats and strings. And then we also looked at more complex data type or composite data type that lets you store integers and strings and floats and give some structure to your data. Namely, we look at lists and dictionaries. And we finally took a bit look at using conditional branching, so if and if else's to be able to give a bit of decision power to your code. So we're going to continue along. I'm going to actually start where exactly I left off last time. And that was along exactly when I was talking about how I can combine conditions to come up with a bit more complex checks. So just to motivate you, so say, as earlier I was speaking how, for example, you can use Python to develop some sort of like web interface or web application. One of the common things you have to do might be to do some sort of a username password check. Maybe you want to restrict access to your application to only people who has registered. So here's my very simple take on it. So what this does, and hope you understand, is that it asks for username and password. And here what I have is I basically have very much of a pre-specified username and password combination. So basically saying only if the username is Edgar and if the password is my password, it's a very strong password. And then I actually say, okay, this is fine. You're allowed to log in and proceed. Here, there, of course, it does nothing but just print appropriate messages according to whether you are accepted, whether the username and password matches. Or in any other condition, it says, okay, that's not the right combination. So go ahead, run it. It'll obviously ask for username and password. So first round, I'm going to try to type it correctly. And under the right combination, it says correct password, welcome. So this is just a quick demonstration of the AND, right? So if you can see that it first makes sure to check the username is equal to Edgar. And the password has to equal my password. So AND means if either of these conditions is not equal to true, it doesn't match, then overall the whole condition is false. So it will skip to the else block. So you can kind of like, let me just do one more time. This time I'm going to put the right username, but my password is wrong. So it would be wrong username and or password. Okay, so far it should be pretty straightforward. Hopefully it makes sense. Okay, that's all nice and simple, but the problem is, of course, as a program, this is pretty boring. It only lets one user with one particular password log in. And I mean, unless you imagine this is just going to be something you develop for one and only one person, this is not how you want to use your username password combination checker. Ideally, maybe what I'm thinking is I want to be able to specify multiple users and their corresponding passwords. So perhaps in the form of dictionary, right? I call that dictionary passwords, where keys are the usernames, and passwords, and then the values are the passwords. So using this, I will actually like to improve my password checker so that if I put any username and password combination, it looks them up in this dictionary and then decide if it's correct combination or not. So in order to do that, I have to introduce you to this concept of membership check. So when you work with lists and dictionaries, it often happens to you actually want to see whether some value exists in the list or in the dictionary. And the one way, or the way to do it, is by using this in keyword or in operator. So let there be a name list called names, where I list Tom, Sam, and Paul. And I'm curious to see if the value Tom is in the names. All you have to say is Tom in names. And this is a check. it basically returns true or false according to whether the value Tom exists inside the list. So if you go ahead and run this, it says true because Tom is indeed in the names list. If I change this to anything else, like for example myself, is Edgar in names? False, because that's not part of the list. You can do something very similar when it comes to dictionaries as well. But of course, when it comes to dictionaries, when I say, is this in a dictionary, it may be a bit ambiguous to whether you're asking, is it among the list of keys or is it among the list of values of the dictionaries? So when you ask whether something is in the dictionary, you could also specify in the dictionary keys or dictionary values by doing dot keys or dot values. So here if I say, is character or string A in mapping dot keys, this is asking among the list of keys in the dictionary is A inside. If I run it, whoops, I actually have to define this first. Define the mapping. If I run it, it's true because A exists as a key in there. And if I'm interested about as a value check, then I say something in mapping dot values. Okay? Now it actually turns out that because checking for keys is the most common thing to do, if you just take any value and ask in the dictionary itself, by default it looks among the keys. So if I say F in mapping, this is understood to be the same thing as F in mapping.keys. In this case, it's not among the keys, so this should return false. Okay, so far so good? Okay, so now armed with this ability to check if something is among the keys, and given that I know how to check values of a value or a value that corresponds to a key inside dictionary already from our exercise last session, I can try to improve my password checker a bit better. So again, I'm defining this passwords dictionary, and I'm going to try to improve. So this is going to be the first exercise we're going to walk together. I'm going to try to improve this code so that instead of being very specific to one user and password, it's going to do two checks. First, given a username, it's going to check, is the username even in my dictionary? If it's not in the dictionary, he's not a registered user and not even worth checking anything else, right? So that's the first check. And if the user is in the dictionary, well, of course, the question is the password that person given match the password for that user? Okay, so let's try to tackle this. So everything could pretty much stay the same. Only part that has to change is really the if condition. So the first check is, okay, my username, which is going to be in the variable username, is this in my dictionary? So here my dictionary is called what? Passwords. So I want to check if username exists in the dictionary. So how could I do that? Yeah, so you could say username in passwords. You can actually just say passwords because by default, exactly, it checks among keys. So this alone basically checks, okay, is the username among the usernames listed as keys in this dictionary? So I could already run this as is, right? And then if I enter a name, so here Edgar exists, so let's try Edgar. It's going to ask for password. Let me put some gibberish in it. But here's only checking for membership. So if I do this, it will actually say, correct, password, welcome, right? Because it's only checking for membership. So we are one step closer to what we want, but not quite exactly where we want to be. So obviously, user password check is not just about whether username is registered, it's also about getting the password right. So given that username is in the password, we also want to check, okay, did the password match? So I know the password the user entered is in the variable password. So I'm curious whether password he entered is equal to the password for that user. So the question is, how do I get the password for the user? Where's the information listed in? Passwords. Yeah, well, so it's in the passwords, right? So I could say passwords. Now this is the dictionary passwords, right? And I want to look at the password for that particular user. Well, the key are the usernames. And if I put the key, I get the value corresponding to it. So I can just say passwords, usernames. I'm looking up the value for that username, right? And then I'm saying, okay, did the password the user enter equal to the password in the dictionary matching that username? Does that all make sense? Good. Okay, so now with this, let's check. Again, I'm going to try Edgar and put some gibberish again. And this time it correctly rejects. So go ahead, give it a bit of try. It should work according to what's actually put in. So obviously for John, he probably put his birthday in. So yeah, these are all collections of extremely great passwords that you might see. Probably not the best ones. But this is just to illustrate that oftentimes you do want to combine these things, like combine checks. And sometimes the second check actually depends on the first check. So one thing about AND, it's a bit, perhaps a bit advanced or maybe something a bit to think about, is that if you have two conditions ANDed together, as soon as the first condition is false, it actually doesn't do the check on the second because you know the whole thing will be false. So that's called short circuiting. So in this case, the reason this is all good and useful is because if it's the case username is not in the passwords, the second check will actually fail, as in the case trying to access the value for a key that doesn't exist in your dictionary couldn't actually error out. But it wouldn't happen because the moment you say username and password is false, meaning that key doesn't exist, it just stops. The whole thing evaluates to false, and it doesn't even get to the second check. So hence you avoid the error. So oftentimes you make use of the short circuiting to be able to say, okay, conceptually it's like saying, well, if the username is registered, then what's the password for the username, right? You don't do the next portion.
I don't remember. Do you guys use ampersand in Python?
No. Yeah, that's right. So in Python, we don't use the ampersand. Well, it's a bitwise logic, and if you use ampersand, which means you're probably not going to ever use it, except unless you do embedded programming or something like that. So correct. In Python, these things like AND is like AND spelled out, OR is OR spelled out, and if you want to invert something, you put NOT, like NOT in front. You don't actually use the. In other languages, you could typically use something like ampersand, pipes, the bars, and the NOT would be an exclamation mark. That's not how it's done in Python. Okay, so far so good? Make sense? All right. So that's just like one thing I wanted to go over in terms of like endings. Now what I want to do is the second kind of the flow control, which is the loops and repetitions. Okay. So one of the most common thing you want to do is like if you're given a list, you often want to visit each and every element of a list and do something along with it. Maybe all you want to do is just print every element of a list, but that's still something that you wouldn't want to do manually. You wouldn't want to, like once you're given a list, you don't necessarily want to say print list bracket 0 and then print list bracket 1, so on and on, because that just doesn't seem right, right? That doesn't scale well. There got to be some more systematic way by which you can do. Well, that's precisely what for loops are for. So with the for loop and with the syntax of for something in list, where x is just a variable you decide to give, and list is a list, it actually visits each element of a list, assigning the value inside the list into x one at a time, executing inside the block of code inside the for loop. So a lot of them me trying to explain in words, let's just take a look at it. So here I have a list of a couple animals. And here's a syntax I have which says for x in animals, print x. So what this will do is that it will visit each element of the animal. So it will go from dog, cats, on and on. Each time the value inside the list gets assigned to x. And then whatever is inside here gets run with that value of x. So here if I were to run this, it obviously prints everything in the list one line at a time because you're printing each of the elements with the print statement. Yeah?
You haven't defined the x.
Well, so yeah, you don't have to. So the fact is that it gets defined in this syntax. It's the fact that x, if you put it this way, it understands that all it has to do is go through each element, assigning the value in the list into x. And in Python, you don't actually do predefinition of variables anyway. Okay, makes sense? Yeah.
So after that for loop is done, does that x now retain the last value?
Yes, very good point. In fact, that is the case. If I go and say x, it contains the last value you visited. Sometimes you use this, many times you don't, but it's a good thing to keep in mind. Okay, so let's just say. So, okay, now that one quick exercise I wanted to do is I want to now be able to do a bit of filtering of the list. So instead of just listing and go through every element of list and print everything out, which is exciting at the first but kind of gets boring pretty quickly, I want to do something a bit smart, right? So how about I actually print out a name of animals that starts with D. Okay? Now in order for you guys to do that, I have to introduce you to one quick thing, is this idea that strings are actually indexable and sliceable. So if you remember from the Tuesday session where we talk about lists and how you can access indices in the list and look at, say, it's the first element of a list and you can take slices in the list, it actually turns out you can do the same thing with string. String is kind of like a list. So if I pick a variable and say my name in it, if I say name 0, this actually gives you the first character of the string, which in this case should be capital E. And I can also do slicing, and here I totally lie with my comments when it means last 5 characters. So if I say last 5 characters or minus 5, this is slicing the last 5. So if I do it this way, I get the E when I index the 0th element. And if I do minus 5 colon, this is the slicing we've done for a list. Same thing could be done here. So this is the same thing as saying, give me the last 5 characters of this string. Okay? So now you know how to get the first character of a string. Let's try to actually do the question of, solve the problem of only printing out if something starts with character D. So again, I have a list of animals. I'm visiting each element one at a time. But before I print, I want to do some check. Yeah? Something? Okay. I want to do some check, right? So I want to print it only if it meets a condition. Here, the condition is that it starts with character D, right? So remember, X always contains the current iteration. So we talk about this in terms of iterations. Current iteration's name of the animal. So it could be dog, it could be cats. It just depends on which iteration. But every iteration, the X contains that name. So I'm interested in the first character. And I want to make sure that this is equal to D. So if it's equal to D, I want to print it. So with this, I indeed get the filtering. So this is pretty common operation. We often refer to this as filtering. I've been already referring to a couple times of filtration. So when you have a list that contains a bunch of elements, sometimes you want to narrow it down to some elements that only meets your specific criterion. So that's the filtering operation. You filter out anything that doesn't match your condition. Okay? Make sense? All right, so now we learned how to visit lists. Let's also do something that's also very common when it comes to looping, which is actually working with a bunch of numbers. So say, just for the sake of it, you want to count up from 0 to 9, printing each number on a line by itself. Now, of course, if I say I want to go from 0 to 9, I could come out the list, manually define to go from 0 to 9, and just print it using the same exact thing we've done. Now notice that earlier I was using variable x, here I'm using variable n. It really doesn't matter. The variable of the name of the variable you use for the iterant or something that you iterate through is totally up to you. So make sure you pick a name that makes sense. So here, in fact, since I was visiting animals, I could have just coded this for animal in animals. But I typically try to avoid that because that's a plural versus singular difference. The only difference between two variables. One is a list. One is something you're iterating. It's just one character S. It tends to be not as easy to spot, so I tend to avoid it. But when you come across many people's code, you might see that that's the way that people do it. So here I'm just saying for n in numbers, so I just visit every element of the list. I'm just printing. So this is exactly the same thing as we did printing elements of an animals. Here I'm just doing with numbers. So obviously this works. Goes from 0 to 9 and printing. Okay, it works kind of nice. But the problem is, like, what if I actually now want to go from 0 to 100? I don't really want to type 0 to 100 in a list and then print it. It almost feels like I could have just printed by the time I finished typing into the list. So of course there's a convenience function for that. Python comes with this function called range, that if you pass in a number, it represents a range of numbers, sort of like a list. Well, but before I say it, it's what exactly it is, let's just take a look at it. So here I'm going to say range 10, and I'm going to store that in variable z. Just randomly pick the name of the variable. And let's look at z. Okay, well, z comes back and say, oh, this is range 0, 10. It doesn't really look like a list. It just says it's a range. Okay, so it's a bit funny object. It's a funny kind of data type that comes back. But it really shows its power true when you start iterating through it. So just like list, you can actually iterate through just with the for in syntax. So if I do for x and z and just print every element, you actually see it represents 0 through 9. Now if I'm just for curious ones, if I were to say, okay, what is exactly this range thing that comes back? It doesn't look like a list. If I look at the type of the z, it says, well, it's a range. So it's a special object called range object. It represents, as you can imagine from the name, it represents a range of integer numbers from a start to the end, not including the end. So if I say range 10, it represents numbers starting from 0, counting up to 10, but not including 10. So that's why if I say range 10 and iterate through, it goes from 0 all the way to 9. Okay? And so, for example, so you can say like, okay, now if I want to go from 5 to 10, I have to say range 5 to 11. So this range allows you to not only specify the end, which is not going to be included, by the way, right? You can also specify the beginning. So if I say range 5, 11, it will print starting from 5 up to, but not including 11. So you get this. Okay, make sense? And just like we did for the list, so now this should look more and more like what happened when we do slicing. Remember the slicing in the list had the start, end, and step, or skip. Actually, range has the exact same feature. You can actually specify the beginning, end, and what to step over, or every n numbers to go over. So if you say starting from 0 up to, but not including 20, every 2, or so every other, it prints, well, even numbers going up to, but not including 20. Okay, that makes sense? So one thing to keep in mind, or one thing to learn here, is that we visited list. I didn't go over tuples, but remember the tuple is the immutable kind of list where if you use parentheses instead of square brackets, only difference being that you cannot change it after the creation. So you can obviously go through a tuple just like you did for a list. You can say for x and a tuple will visit it. And you also now just saw that if you use range, you can also iterate through a range object. So these kind of objects like lists, tuples, and range that you can visit each element one at a time using the for x in syntax, that's called iterable objects. So these are iterable objects, and as we see, we've already seen 3 of these. And we'll soon to be, throughout the course, actually encountering many, many of those, and eventually maybe even defining our own special iterable objects. Okay, so one thing that's interesting about iterable object, by the way, is this ability to unpack. So say I have a list containing 1, 2, and 3. And if I actually use this list on the right-hand side of an assignment and assigning into 3 variables, a, b, c, guess what's going to happen? Well, I mean, there's only probably a couple sensible answers to this. And the one we think would be the potentially most intuitive is probably the answer, in that it unpacks the list. It basically breaks apart the list and assigns each element into the corresponding position variable. So A, B, and C gets assigned 1, 2, and 3 respectively. Okay, so it's a pretty nice feature. Is that sometimes you actually have a list, and if you know the length of the list especially, you just want to break it into a couple of different variables, so now you can like refer to each element. So this happens once in a while, or depending on how often you want to use it. And now I'm actually going to quickly take a look at actual use case of it in what's called enumeration. Okay, so as you visit lists, right, we already saw how you can just go and visit each element and just work with it in the for loop, right? But sometimes when you visit the element, you actually want to know what's the position in the list. Like, is it the first element? Is it the third element? So on and so forth. Because otherwise, you're only given next item without indication of how far into the list you are right now. So one way to do this, and this might be actually more familiar to those of you who've worked, say, in languages like MATLAB, where you actually, it's much more common to first iterate through indices and then index into a list. You might say, okay, I could actually use the combination of range and length. So remember, the len of a list returns how many elements there are. So in this case, len of x for this list would be 4. So if I create range 4, it becomes something you iterate through from 0 up to 3, but not including 4. So it's an index. Now I can use the index into the list to get the ith element. So together I can just print out position in the list as well as the content. So I can get something like, okay, 0th element is A, index 1 is B, so on and so forth. So this is one approach. Okay, you could totally do this. But it's actually nicer, and there's a nicer syntax called enumerate. And I'll first demonstrate how to use it. Okay? So again, I define the same list. But notice this time I'm actually doing for two values, I and B, in enumerate of X. There's a bit of specialized syntax. And then I'm just taking the two variables and printing side by side. But notice it also gives you the same thing as if you did the indexing. Okay, so let's just see what's really going on. So first of all, let's look at what enumerate of an X does. So if I take an X, which is the list, and if I wrap around with the enumerate function, well, it's not that helpful. It just tells you, oh, this is an enumerate. Enumerate at and some very fancy value, which is actually a location in memory. So you probably don't quite care about what that is, right? All you can tell so far is it's some sort of object called enumerate, just like range was a bit of a special object. Well, it turns out that enumerate is an iterable, right? You can actually iterate through. And for any iterable object, or for most iterable objects, you can kind of convert into a list to see what it would be if it was a list. And you can just do that by the type conversion. You wrap it around with the list call. So if I did that, this is the content of essentially what enumerate does. So you can see what enumerate ends up doing is it takes each element of X and pairs it with an index and puts it in a tuple. So remember, this is a parenthesis, meaning that this is a tuple. And the whole thing is a list. So this is basically a list of tuples, where this is the first tuple, second tuple, or like index 0 tuple, index 1 tuple, so on and so forth. Make sense? So if I were to just iterate through this enumerate object and capture the iterate, which is like each of these things. So remember, if you were to visit elements of enumerate, it's a tuple at a time. So if I were to just grab what's returned into E and print it, you actually get tuples. Okay, it's a list of tuples. Okay, finally, then this is where the unpacking comes in. Because I know every time I visit an item of the enumerate, it gives you a tuple. I can either store the whole tuple into a variable, which is what I've done here with E, or I could actually unpack it into two parts because I know it consists of two parts, the index and the value. So that's exactly what I've done. I basically say I comma v in. So this is as if you did I comma v equals to the tuple. It unpacks the two elements, assigning the first number, which is the index, into I for every iteration, and the corresponding value into v for every iteration, giving me I and v. So all in all, combined together, I can just I can just write it like this and print it out. And here I broke it up into separate lines. But remember that the list is actually just there for us to see the content. So if I were to rewrite this in the more typical use case, it would be something like this, just like how I had it previously. Okay. So this enumerate trick of like getting an index at the same time as a value is pretty common, especially as we start to do more scientific computations, because as you visit an element, you often do want to know where in the list you are currently and make use of the fact in either looking up values elsewhere or in itself some sort of computation. Maybe the index itself is useful for you doing some kind of computation. Okay? So I just wanted to cover that. All right, so far so good? Make sense? All right, then the next thing is the iteration of the dictionary. So this is the last among the iterable I want to cover today. So say you actually have a dictionary. So here is like lists of some temperature I just randomly came up with for different cities. I roughly took into consideration what they could be. Probably completely wrong though. So earlier we already encountered keys and values methods. I'll be more details about what exactly a method is later today. But here basically if I take a dictionary called keys on it, it actually returns this list-like object that lists all the keys. So given this a list-like, it's probably an iterable, right? You can actually visit every one of them one at a time with the same for loop syntax. So I say for k in temperature dot keys. And if I print one at a time, it prints the list of keys. Okay? And using the fact I get the keys, I can then index into my dictionary so I can print the key value as such. Here I'm just using the formatting to make it come out look a bit nicer than just key and value next to each other. So this is completely a valid way for you to iterate through a dictionary. If you want to go for every key value pair inside a dictionary, you could totally do this. But there's an even better way to do that. If you actually use this another method called items on a dictionary, it returns this list of what looks like list of tuples. And the tuple is a pair between key and value. So this is just like how enumerate was. Enumerate was a pairing between index and value. Here's a key and value. So you can almost use the exact same syntax where now you have for key and value in the items. So remember, since this returns a tuple at a time with two elements, key and value, you unpack it into key value variable for each iteration. If you print it, you get the key value pair just like that. You don't have to do this extra indexing step like we had to do it up here. Like you don't need this extra indexing. So if you're just visiting every key value pair in a dictionary, this is probably the most convenient way to go around it. Okay, so here I'm just rewriting the earlier code into using key value, and this would be something like that. And last but not least, if you just want to iterate through the values, well, you can probably guess you just replace .keys with values, and this way you can just step through the values of the dictionary. Okay? So far so good? Loops are keeping fine? Fine? All right. Okay, so with that, we covered some basics about loops. Actually, we covered so far quite a bit, and to the point that one could easily argue that with one more thing you learn, which is coming up today, you've pretty much mastered basics of at least 95% of the Python. You can almost do everything you want. So we'll just do a couple exercises with loops where I will mostly walk you through. There will be homework assignment today where it mostly makes you do more loop-based exercises because it turns out that ifs and loops are usually the crux of programming. If you really nail these, then you can almost do anything you want with programming. So I give you more exercises on this. But here are a couple ones I wanted to walk through with you together. Okay, so one of the common things you do with loops is going through a sequence of numbers and doing something with it. Right? So here is say maybe what I want to do is I want to print out square of first n integers. Okay? So first thing first, I want to go through n integers. So you might imagine that will come in the form of range, right? So talk about range being something that gives you access to integer one at a time. But here we want to go from 1 to n. So since n, it's given in terms of n, let's actually first of all just define n to be something. We can even take this via input, obviously, right? I could actually say instead of pre-specifying a value, I could change it to say something like this, like prompt for a number. Right? I could do that. For now, just for testing, and this is typically what I recommend as well. If you're just testing, typically it's just faster to put some fixed value in, test your code, and then make it interactive. So I'm going to keep this code to make it interactive here. I comment it out, right, and put some fixed value for now. So I'm going to want to step through n numbers, but here I want to go through from 1 and up to and including n. So if I say 1 to n, this will start at 1, but it will not include n. So how could I include n? Plus 1. So if I plus 1, then that nicely lets you get to the n, but not get to the n plus 1, so resulting in you getting the first n numbers. So when you program, key is to actually just incrementally develop. Don't try to write the whole thing and then run it for the first time hoping that everything works. It wouldn't usually work. And if you do it that way, you usually have 4 or 5 bugs that would be really hard to spot. So incrementally build up your code. So here, I want to print a square, obviously. But first of all, I just want to make sure I'm visiting the numbers correctly. So here, what I'm going to do is I'm just going to print the numbers out. I expect it to go from 1 to n, where n is 10 in this case. Okay, so far so good. That seems to be working. Then I only have one more step left. I want to print square instead of the number itself. So how do I do squares in Python? What's the symbol? Star star, yeah. So like that, right? So that square is the number. And this time I'm printing the square of the number, and indeed it looks correct, right? And you should always kind of check for multiple cases. Like, don't ever test one case and then conclude that it's correct. Also, test numbers that you don't think make sense. Like, maybe I'll do minus 30. It's always good for you to try a number and predict what should come out and then see if that comes out. Don't just accept because it comes out that way. That's going to really make your programming life very difficult. If you're always very reactive about your programming and just accept what comes out, you wouldn't be able to really spot an error. So here's actually something I haven't quite taught. What happens if you start with 1 and if I go all the way to negative 30? Is it going to go from 1 and then start counting backward? Or, well, let's see. It doesn't print anything. It doesn't print anything because if you give into the range something a negative as an endpoint, it actually would decide like, well, I'm already above that endpoint, so there's nothing more to go beyond this. One way to get around is by actually giving a step. If your step is minus, they understand that, okay, now you want to go backwards. Okay? Okay, so at least this kind of works, and you can, of course, convert it to be interactive, so it actually prints out according to what you input. Okay? All right, next. This time I actually want to do something more mathematical. I want to take the sum of the list. Right, so this is typically also referred to as aggregation. You're doing something with every element and coming up with one number at the end. So if you take a list and like aggregate it into a single number, a single answer, well, the whole process is usually referred to as aggregation, mostly referring to numerical lists. So here I just want to take the sum. So how could I go about doing this? Yeah, so aside from those who know some shortcut, let's actually try to implement it. We'll come back to shortcuts on this one. Well, when you do sum in your mind, like how do you go about doing it? You look at one number at a time and just aggregate it, add them up, right? So let's try it, right? So, okay, one approach would be something like this. Maybe what I can do is I'm going to have a variable called total, which is going to keep track of all my totals. And I'm going to start with the first value. This is approach number 1, right? So I start with the first value in the list. And now I want to visit rest of the list and then add them into the total. So total accumulates the values, right? So I could do that. I can visit the list. The problem is if I did this, it visits every element of the list, right? So I could actually slice it. If I did this, remember the slice? It visits first the index 1 and beyond, so this happily skips the first value. Okay, so now you're visiting everything but the first element in the list. And I want to add this into total. So you can say total plus x, and I want to put it somewhere. Well, we're trying to accumulate, so I can just put this back into total. And let's see what this gives us. 41. So if anyone wants to verify, they can just quickly add these numbers in their head, and it is indeed 41. Okay, so that's so far so good. Let's see if you can improve this a bit. Okay, so first of all, this total equals total plus x. It turns out this happens so many times in programming, there's a shortcut. You can say total plus equals x, and this is the same thing as total equals total plus x. Okay, so I made one change. Let's run it. Okay, still 41, so still good. Now notice this treatment of the first value a bit specially. So I take the first value and then try to add the rest. Could be a bit funny. At least it's treating the first number a bit too special. It turns out like I could just go ahead and visit each element and add it into total, as long as actually total starts with some sensible default. So if total represents the total up to the value you're visiting, it will work, right? You keep on accumulating all the values up to what you already visited. So if you haven't quite visited any element in your list, what your total should be? 0. You haven't added anything. So if I put total to 0, and this time just visit every element in the list and add them into the total, it will still come out correct. So this is the typical implementation of a sum here putting into the total. Make sense? Okay, so now let's take what we have. We have computed total to actually now compute the mean. So that should just be one step away from it, right? So how do you go from total to the mean? What do I have to do? Divided by the total number of elements, right? So how can I know the number of elements? Len, right? So I take the len of vowels. I'm going to just print the mean. And that looks correct. Make sense? Okay. All right, so now let's combine it a bit even further. And this time I want to have a sum of all integers between 1 and n, where n is going to be given by the user. So again, we already know how to get the integer from user. We're just going to say int of input and say something like enter a number. Let's put a space here to make it look nicer. Like that. But again, since I'm just developing, I recommend that you put some fixed number for test for now. So I'm just going to put 5. Okay. And now I just want to loop through a list of integers, right? So whenever you have to go through integers one at a time, it's range. Pretty much always going to be range, right? So it's going to be range. I want to start at 1, and I want to go up to and including n. So if I put n, it doesn't get to the n. So obviously the trick we visited was n plus 1. And now I'm going to visit each element in it, right? Now I want to take the sum of this. Well, here I already implemented going through the elements. I already know how to do the sum from the earlier exercise. So I can just say total equals 0. Oops. And then here, total plus equals x to sum them all up. And now if I actually run the whole thing, it says the sum from 1 to 5 is 15. This is correct, by the way. Okay. And then finally, I can make it interactive by uncommenting this. And now it's going to ask for a number, and it will tell you the sum. Okay. Good so far? Make sense? All right, so then the next portion I wanted to do is conditional data aggregation. So this is combination of filtering and adding. Basically, the key to programming also is like as you accumulate more and more tricks, you just start combining them, and you arrive at more complex looking code. But in reality, all you have done is just combine together some simple steps. And pretty much any code could always be divided into simple and easy to understand steps that, when combined together, does quite impressive things. So here, again, we want to do total. So here, maybe what I will do is just implement the total again. So it's summation before I do anything, just because we already done this a lot. Okay, so that takes the sum of all the values, right? But that's not quite what I wanted. If you look at it carefully, it says I want the sum of all even elements. So before I add it, I have to check whether the number I'm adding meets that criteria. So whenever you have to do a check, what should you be using? If, right? Okay. So you should say, okay, well, let's check. If, I want to basically say, if it's even, then I want to add them up, right? Oops. I want to add them in. This is not happy because of this. So how do I check if it's even? Remainder, right? You guys remember from the 2 days ago exercise that we can use modulus operator? So if I say this, gives me the remainder of the division by 2. If it's even, yes?
How can you tell what's inside or outside of your
Good point. Good point. Actually, I should have stressed that. Sorry. You can tell based on indentation. So in Python, they actually tell what's inside based on if it's indented or not. So as soon as, for example, so if I were to say something like this, and I should have demonstrated that. Maybe I'll do here. For I in range 5, print I. If I say print hello here as well. Then you see it says 0 hello, 1 hello, right? If I unindent this out like this is no longer considered part of the loop, so hello occurs only at the end. So the Python tells apart what's inside a conditional or looping block based on the indentation level. So here, yeah, we're actually combining multiple indentations. So here saying for, the block of the for loop is basically everything that's still indented. And the block of if would be what's inside here. So let me complete this. I want to check if it's even. So I add only the even elements this way. And if I add them up, it's 24. And you can quickly verify that 4 plus 12 plus 8 is indeed 24. Now if I wanted odd numbers, add them up together, how do I do that? Equals 1, right? So odd number has a remainder division of with 2 to be 1. So if I do this, it adds the odd elements up. Let me put it back to the even. Okay, so let's just do 2 more examples before we move on to the second block of today's session. So this one is another filtration. This is pretty much exactly what we visited earlier. So here I want you to print words that only words that starts with A. So again, all in all, you always just write the loop first, just to make your life easier. Here I'm just using variable v for no good reason actually. I'm just randomly doing that. And here I'm just gonna go ahead and print everything first. All right. So just start with something very simple and get it closer to what you want. So here at least it visits everything and prints everything out. So that's working. So this should kind of start to become your second nature. Now I want to limit the printing. I want to print if it only matches my criteria. And my criteria is that my word begins with character A. So we already know V is the one that contains the word. How do I get the first character? Index 0, right? And I want this to be A. And I'm doing conditional, so this has to be O and if. And the print has to be inside the conditional. So basically saying if the word starts with A, then print it. And that's how I get it. Okay. Now, what if I actually wanted to say, like, if the word ends with the, say, I don't know, E, I want to print it out. What would be the most convenient way to get the last character? Do you guys remember? So 0 indexes -1, right? So that's the indexing from the back. So if I now say last character is equal to, what did I say, E? There's only one word that matches it. Okay? And you can arbitrarily do it. You can maybe say, oh, I want the second character to be A. There's only one word that matches it. So you can make combinations of these things. But here I'm going to put it back to what the problem states. All right, last but not least is this tallying results. So this could be actually fairly practically and actually realistic situation where, say you have a list that contains a bunch of yes and no's, maybe with some sort of voting. And now you want to just tally them up and figure out, okay, how many yeses are there and how many no's were there. So it has a bit of feeling of total, right? You're accumulating stuff, but you're just more incrementing every time you meet some number, meet value, right? So one way is to, well, first of all, it sounds like you probably want to visit every element of votes, right? You want to look at one vote at a time and then tally them up. So since there's this loop or iteration feeling, let's just go ahead and put that in first. So I'm going to say for V in votes. Okay, so for now I'm just going to print it. Okay, just prints all the yeses and nos. Now what I want to do is I want to actually tally them up. If it's yes, I want to increment the count of yes. So here I'm already giving you a dictionary with key of yes and no, each starting with 0 because I haven't encountered any. And I want to increment that number. Well, I could basically say, well, if the V is equal to yes, then you can say, well, the tally of the yes so far, I can add 1 to it and reassign. Right? Now obviously this in itself could be written more shortly by saying this. Right? Just increment it into place. And then I could say else tally of no gets incremented. So I could do that. Okay, so that seems to work. But there's actually an even nicer way to write than this. So let's maybe I should just copy this over. In fact, yes and no is exactly the key to your dictionary. So every time you actually encounter yes or no, you know which entry you should be dealing with, right? So I can do is instead of this whole block like that with the if and else, I can just say tally for the v, right? So if it's yes, it will be looking at the tally for the yes. If it's no, it will be looking for tally for the no right now. And for that one, just increment it by 1. And it works just the same way. Okay? So using dictionaries can actually often let you skip the if and else checks. You can actually use this key of the dictionary in smart fashion to write a shorter code. So when it comes to what's correct, what's wrong, there's no correct, there's no wrong here. They both do what is exactly expected out of them. This works just fine, and this works just as fine. But conceptually, I mean, okay, this is arguable, but conceptually, once you get through it, this could be treated to be simpler, right? Especially now, say, what if you also want to tally up maybe? All right, and let me just insert maybe a couple of times. All right, and then I should just print another extra lines. There are okay, like that, and I'm just gonna say tally of the maybe. So notice that I just had to change my dictionary. I just have to input some votes for maybe. And I don't actually have to touch this at all because it will correctly tally up for maybe anyway. So if I print it out, oh, except it didn't work. Format, yeah. Yeah, so this is actually one thing I forgot to mention is that typo is the single source of the single biggest source of errors in your code. So yeah, make a lot of typo mistakes, so you actually encounter as many variations of the error as you can see. You'll be encountering them all the time. Like I think on session 1, I magically didn't make a typing mistake, but that's completely anomaly. Usually, there's a lot of typo I make all the time. So that is indeed the single biggest source of errors you encounter. Okay, but hopefully you see that although both of them work fine for yes and no, if you actually start changing your data, it might be the case that one is easier to expand compared to the other. So that's something by which you can decide one is more like future-proof in some sense or more, I don't know, flexible. And as you do more and more coding, you probably tend to prefer flexible code because down the line it saves you some time. Okay? All right, so that's all we'll have for loops. And now I want to quickly go through functions. And if I have time, object-oriented programming. If I don't quite finish object-oriented programming, I will cover that at the beginning of the next session. All right, so functions, actually turns out function is a pretty straightforward topic because what we've been so far talking is really the meat of the programming. Is basically learning how to use variables, dictionary lists, and then loops and ifs to achieve what you want. But what happens, like if you write a lot of code, you tend to see that you tend to get a lot of repetitions. You actually repeat the same logic over and over. In fact, in just a couple last exercises we've done, you saw that this summation or coming out the sum of a list came up so many times, we already rewrote that thing 3 times or 4 times, right? So a situation like this occurs all the time in that if you always just write out the whole logic, and let's say down the line you actually want to make one tweak to every instance of this, now you have to go back and find everywhere you actually type that code and try to make changes everywhere, right? And you can easily miss 1 or 2, causing some discrepancies in the results. So it'd be much nicer if you can just write it once and keep on reusing it so that if you have to change it, there's only one place you have to change and change gets applied everywhere. Well, that's precisely what functions are for. So let's actually say I want a function that when I call prints out this very nice message, hello world, of course, right? The way you write functions in Python is you start with diff keyword, and then you give a name of a function. Here, open close parenthesis, we'll get back to what is this for pretty shortly. And colon to indicate the end of that line. And then you put indentation, and that's where you put the code that corresponds to your function. So here I'm defining function. Defining in itself obviously doesn't run it. It just defined the function. You use the function by taking the name of the function and then calling with the open and close parenthesis. So if I do that, well, it prints the message hello world. Okay. Well, so this is nice. At least you wrote a function, but this is not that useful. Probably what you want to do is have a function that probably takes in some input and change the behavior according to the input. Well, that's what this close parenthesis was for. You specify the parameter that your function takes in, and you can use the parameter inside your function. So you're basically saying my function will accept one value. It will be called name, and I'm just using that in what I print out. And when you call a function with parameter defined, you pass in the value as the argument to the function. So notice that slight distinction I'm making between the two words. Parameter is from the perspective of the function. So inside the function, name is the parameter. When you call a function, what you pass in is an argument to the function. Okay? It's a subtle point. You can almost use it interchangeably and you'll be fine like 60% of the conversation. Sometimes though, making that distinction will help you make it clear when you talk about your functions or when you're talking and trying to describe your function to others and trying to debug stuff. Okay? So just be aware, argument is what you pass into the function. Parameter is the value that the function will receive and use inside the function body. So here I'm passing in Edgar, the string, as an argument. And now it uses that in printing out the message. Okay? Yeah?
So the argument is the specific value, the parameter is the general determinant.
Precisely. Okay, so far so good, right? So here I'm just basically saying parameter versus argument thing again. Okay, so even better is when a function returns something. So maybe you want the function to compute something and return the result of computation. Well, you do that by return. So now here I'm going to write a very nifty function that takes in a number and returns square of the number. So I'm going to call it square. It takes in one parameter. I'm going to call it x. And it squares it. So x star star 2 to square it. And then returns the value by return. Okay? So let's try using it. If it returns, you can use whatever is returned to assign it into a variable or just print it out directly. Or you can do whatever you want with it. So here if I do this, square x, I'm calling with the argument x, which is 5. So it computes to be 25, returns that value. I'm taking the return value of 25, storing it to y, and then just printing it out as 5 squared is 25. No.
What's the difference between return and print?
So print, okay, yes, that's a very good point. Print is actually just a message out. So in fact, if I were to just say print it here, and try to use it, you see it says none, right? It's because the function just printed out on the screen for you to see, but it really didn't return anything. So if you were trying to say y equals, well, function itself didn't return anything. So there's nothing to assign into y. And I was going to talk about none pretty shortly, but none, as you can probably imagine, just indicates nothing was returned. It's an empty value. Okay. So if you want it to be usable down the line, the result of your computation, you have to return the value. So let me put it back. Okay. And here I'm just defining yet another function. So a function can take more than one arguments, more than one parameters. So here I'm defining two parameters, a and b. I'm using both of them to compute the product, and I return the result. So now if I call with 5, 3, it takes the product and returns the value. Okay? All right, so here what I wanted to show is like, okay, since we've done so many times computing the total and then also done the mean of a list, let's write one function so we don't have to ever type that thing again, right? So here x is going to be a list of values. That's how we're going to assume, okay? You're basically, when you write a function, you have to assume something about what's going to be the parameter, or you define what's going to be the parameter. Yeah?
So these functions were defining our function and we're using it, but is that function still going to be defined as that if I in a
different environment?
Yeah.
Good point. No, but we will actually talk about how to define it and store somewhere so you can reuse it elsewhere. Right. But if you define function here, this function exists only here because you define it there. If I were to start another notebook, the function wouldn't be present. Okay? But we'll talk about how to get there pretty shortly, actually. Okay, so let me just quickly do it. Since you already seen it, I'm just going to be very quick about this. So I'm going to say total equals 0 for v and x. I'm going to say v total plus equals v, and I'm just going to return total. Okay, but that's not quite what I wanted. It's mean, so I want to say total divided by length of x. Okay, so notice I can do actually more computations on the return line, right? I don't have to store this into yet another variable. I could do this obviously, but since if I'm only creating a variable just to return it, you might as well just return the result as soon as you get it. So here I'm just saying like return total divided by length of x, and that works out just fine. Okay, now I've defined this, I can happily just run it. So I have a functional mean function defined, right? That you can keep on using it. So this is how you can save yourself from typing over again. In fact, if I were to do this, another way I would have done this, and this is just to show, I could have also defined total, right? And here I'm going to say s for sum. There's a bit of reason why I keep on avoiding the word sum. I'll get to it very shortly. S plus equals v, and I can return s. And so now this defines total. So actually inside my mean, I could also just say total. Well, here. I can actually just do it all in one line if I really want to, like that, right? So you can like reuse your own function in your next function definition. This is how you can build up more complicated functions. So now we have something that takes the sum, which is a total, and something that takes the mean, and they still work. All right, so one thing I just wanted to point out is like, okay, what happens if I take the mean of an empty list? This is one of those corner cases, things they probably hope not to encounter, but okay, you will encounter, and you want to be aware of what will happen. Sometimes you actually have to be explicit and deal with it. So here, any guess what happens if I take mean of an empty list? Would it be like 0? Would it actually be like error out? What's your guess? So just to give you a sense, if I take a total of an empty list, it gives me 0. Okay, so would mean be 0? Well, it errors out, and what's the error? Division by 0. Why did that happen? Because len, right? Because you divide it by len here, and len of empty list is 0. So if you divide it by 0, well, that's 0. So this is one of those cases this is probably okay. As in like, I will even say like mean of empty list returning an error, like 0 division error, is descriptive enough. It makes sense that I'm fine leaving it as is. But if you feel like, okay, this has to be explicitly dealt with, maybe you want to say, well, if you have a belief that, okay, mean of an empty list ought to return 0, then you could say something like, well, len of x equals 0. If it's 0, you return 0. Now notice here, I'm not going to have to do else. What happens is at the moment you return, you're quit out of the function. Okay, so this is way by which you don't have to put if else here. Because by the time you're here, it means that you didn't go there, right? Does that make sense?
Is that because of return?
Just because of return. It's a feature of return. If you encounter return anywhere in your function returns the value and immediately quits. Okay? So here I'm redefining my mean to basically return 0 if it was length 0, and now it returns 0. I'm not sure if I like that, but this is one way to define your own behavior for your function. Okay? All right, so a couple more things. Default values for parameters. When you're writing functions, and especially if you get more and more parameters, which is not going to be quite the case with some simple functions we write here, but as you get more and more parameters, some of those parameters are there just to tweak the behavior of your function if you want to. You want it to be kind of optional tweaks, right? In the sense that if a person decided that they don't want to tweak it, you want to give some default behavior. Well, that's what's actually pretty easy to do in Python function. So here, for example, I'm writing a greeting that takes in a name and say hello, whoever. And if I call this without the name, well, it errors out because it's expecting that value. But say, what if I wanted to make this somewhat optional? Like if I don't specify, I just wanted to like greet, everyone, maybe just greet the world. So I can do that just by saying, well, name equals world in the definition. And what this says is that, well, if the name is not going to be given, it by default is world. So now if I redefine the function with this new definition, if I call the greeting without passing in anything, it will say hello world. Now obviously if I give it something more specific, like my name, it will say hello Edgar instead. So this is a way by which you can give default values, default behaviors. So not every parameter in your thing has to be, in your function has to be specified. Okay. I think one reason I love Python is for this feature. It's like some other languages, like namely like MATLAB, don't have this feature. As in like being able to give default is really, really clunky. It takes a lot of code to give a default behavior. And as you write more and more complex function, especially some sort of computation, maybe you write one big function that does some sort of optimization on your piece of code, like it computes the maximum value or minimum value and finds a parameter that gives you the maximum. There are many things that you want to tweak. Maybe you want to tweak the algorithm. Maybe you want to tweak the boundaries of the inputs. But oftentimes you also just want to go with the default. Not everything applies to your specific condition. In those cases, you don't have to have to define every single thing that your function accepts just because it can. If it's irrelevant, you'd rather leave it undefined. And default value lets you do that. Okay? All right, so with that, this one thing I just wanted to cover would be none. So we already kind of seen it, but none indicates absence of value. So if you just interestingly type none, you notice it doesn't actually show back. So unlike, say, if I type in 5, notice that it shows back, it comes back with 5. If the value is none, it doesn't give back anything. It's an empty value. So if I say A equals none, and if I say, okay, what's in the A, it doesn't say anything. So this is to indicate that it contains none. And none could be used to therefore indicate absence of a value. Like maybe you just didn't specify it, but you still want the variable to be there. So it's different from variable not defined. It's just the variable is defined, it's there, it contains none. It's just not specified any value in it. So if I say equals none, the typical way you want to check for none is not equal to none. There's a lot of reasons why you don't do A equal to none. You simply check A is none. That's the syntax you use to see if something is none or not. So here, A is none. So if A is none is checked, it's true. It says, okay, it's not initialized. But later, if I take A equals 100, and this time I want to say if A is not none, so means some value exists inside it, then you say it's not none. That's going to be the check. Here, this would be true. It prints out the value. And this would be useful, say, for something that takes in maybe a list, expects a list, but it actually can also work without the list being given. So maybe here what I want is a new function called print messages. And if you give a list of names, it will print the messages targeting each and every one in the name list. But by default, you don't have to give a list. So the default will be none. So this is an optional argument. And in my code, I check if name is not none, meaning did the person actually call this function with a real list? If that's the case, or at least something. And I'm going to assume if it's something, it's going to be a list. Then I'm going to visit every name and print the message. But if it's none, which is the default, meaning that they didn't give me anything, then I'm just going to say hello world. So you can see that if I call it without a list, so this is the case where name is equal to none. This if name is not none fails, it's false, so it goes to the else, and it just prints hello world. But if I actually give a list of 2 names, well, it's not equal to none, so that it becomes true. The first if condition will run, and it's a loop. It will just go visit everyone and print out a message, so it prints out targeted messages for each names. Make sense? All right. Okay. Oh yeah. So one thing about function is the fact that if you pass in a mutable object, do you guys remember mutable object from last session? Right? So some simple ones like string, integer, floats, actually booleans as well you've encountered already. Those are all simple. They're non-mutable or immutable. Once you make it, you cannot technically really change it. Any behavior that makes it look like you're changing, you're actually creating a new object that corresponds and references changes, right? Mutable objects like dictionaries and lists actually can change in place. So one thing to keep in mind when you're working with the mutable function and when you pass them into a function, or mutable object, and when you pass them into a function, is that function can totally change your mutable object. And you have to be aware of that. So for example, maybe I have a list of some nice recordings I've done on my animal, and then I'd store in values. I'm pretty happy about it. And a friend of mine gave me a function. I sort of kind of trust him, so I decided to code a function with my list. And as far as I could tell, it really didn't do anything useful. So I was like, okay, this is probably broken. And I look at my values, and this time I happened to notice that he changed my list, right? But notice that the whole point being that a function can mutate your object if it's a mutable object. This might be unexpected and desired behavior, or if you actually didn't quite understand the function, or there's some miscommunication, or simply a bug in the function, this could actually be an undesirable behavior. So just be careful, right? When you're actually passing an immutable object, you kind of want to know, one, what is this function going to really do with your list or dictionaries? Is it going to change it? You want to know whether it's going to change it or not. And if you really have a hard time trusting it, you might actually want to make a copy of your mutable object and pass it in. So this way that your original stays the same. We'll deal with making a copy when it comes to more relevant portion in session 3. But just something to keep in mind, because this could sometimes catch you with a surprise. Okay? All right, so enough said about writing our own functions. Let's actually deal with a more real-world situation where, yes?
So, I understand correctly, if I have, for example, value 2 equals value, and then I call function change with values, and then values 2 will also change.
That is correct, because they're referring to the same object. Yeah.
Feels terrible.
Yeah, exactly. Yeah, so okay. So the way to deal with this is you can actually make a copy. So let's actually quickly just demonstrate what Sean was saying. So if I were to run, like define this, and if I will say values 2 equals values, and then if I do change list on values 2, right? And if I look at values, well, values is also modified because they're talking about the same object. Remember, they're just referring to the same space and same object that lives in the memory, right? Now, instead of this, if I actually were to look at, let me just redefine it, and I make a copy of my list, then value stays intact. Well, obviously, if I look at the values 2, oops, if I look at the values 2, that has changed. Okay, so yeah, I mean, I guess I end up showing the copy, but here's the one. You can actually make a copy of it. It becomes a bit tricky if you start having like list of mutable objects, or mutable object that contains mutable objects, or mutable object that contains mutable object that contains mutable objects. Then what we have done is what's called a shallow copy. So that means like you come out 2 containers, but their content's going to end up being the same. So if it's a list of lists, the outer lists are different, but inner lists would be the same elements. Yeah, I think this is much better given with the description. I was going to have a lecture, like part of lecture, probably session 4, where I demonstrate this. For those cases, though, this copy is not going to be enough because it's considered to be a shallow copy. What you need is something called deep copy, and there's a special function for that. But that's for that time. Okay, well, along that line, though, so defining your own function is all good, but it will be quite a bit of work if you ever want functionality, you have to define it from scratch on your own. It would be kind of nice if language comes with some set of common use functions. You don't want to define every single thing on your own, right? Well, that's precisely what the built-in functions are for. So little did I tell that there are actually built-in functions in your code, in Python, and one of them is obviously sum. Sum is a built-in function. It takes in a list and just gives you the sum. So all the effort we spent coming out the total function was actually sort of wasteful in some sense, but at least it was a good lecture point. So in reality, if I ever see you define a total function or some function on your own, I'll be quick to point out, hey, just use sum, right? You're just going to duplicating effort, yeah.
So you define a sum.
Yeah. So I have that's why. So if you look carefully, I never use the term sum. I didn't. Yes, I've been really avoiding it, despite the fact I really wanted to use that term. So if you haven't defined sum, this sum should be the built-in function. So let's just quickly try it. So if that ran, this you should be fine. You're referring to the built-in function. You can tell something is a built-in or special keyword because if you look carefully, it's in green. You just notice that? Like sum is a keyword, so it's actually in colored. Now, One thing about built-in function is that they're just names that comes with definition. So you can actually overwrite it, unfortunately. So if I say sum equals 10, I could totally do that. And now if someone else tries to run this, this makes absolutely no sense, right? Okay, so if you encounter this, what you could do is you can happily just delete your variable. And if you delete your definition, by default it goes back to the built-in version of it. So this starts working again. But in general, when you actually start typing in something and it changes color, please don't assign it, right? Unless you really know what you're doing here. Okay, maybe you want to actually change the behavior of some function, but if it looks green, think twice or 3 times. Okay, so there are other couple built-in functions like max. You give it a list, it gives you the maximum value. Min gives you minimum value. Now, one nice thing is for any function, if you just take the name of the function and put question mark behind it, it actually gives you a documentation on it. Right? So this lets you know how to use this function. So here, let's just go through this one together. So it's a doc string, so that's a documentation on it. It says max should be called with either an iterable. I know it's like a cryptic interface, but this is like iterables. Remember the iterable. Iterable refers to things like lists, tuples, range, right? All the things you can do for loops on. So if you pass in any object that is iterable, and star of these in the bracket means these are optional, so you don't actually need to put them in. So if you put that in, it will take the max and returns a value. And what it really returns is defined here. With a single iterable argument, returns its biggest item. So okay, that makes sense. There are also some other, with 2 or more arguments, return the largest argument. So that's another way you can use max, is that instead of passing in a list, you can actually do something like 1, 2, 3, 4, 5, like give out values, comma separated inside the parentheses, and it returns the maximum element within as well. So those are 2 ways of using the maximum argument, maximum function. Make sense? Okay, so this actually brings us to the point of, okay, well, it was really nice these functions had documentation, right? As you write more and more complex functions, or even actually for simpler functions, you should document your own code. So people know how to use your function, and also you know what the function was about. Because remember, after 3 months, you're not going to remember what you did, right? So you want to be nice to other people, which in effect just be nice to yourself in 3 months, right? So the way you define documentation is actually pretty straightforward. All you have to do is that as soon as you start a function, you do this triple quotes and then type in your documentation and end it with triple quotes. This is called multi-line string. And the first multi-line string in the function is going to be considered your documentation or doc string. And you can see it by, if I run this, and now if I do mean question mark, it brings up your documentation right there. Okay, so it was a simple line, but of course you can go on and on. It's like, this is my super efficient, implementation of mean that everyone should use. And it gives you that description. Okay, I mean, be helpful, be descriptive what this function takes. So for example, better documentation for this would be, well, actually I already say mean of list x. So the key thing you always want to do is define what it accepts as an input and what it returns. So here I succinctly said returns the mean of list x. You can also be a bit more descriptive, like x has to be a list of numbers, so on and so forth, to some reason, right? You don't have to spell on and on. If you start explaining how to create a list, then you're being way too descriptive, right? You can assume certain knowledge about the language, but try to be helpful. All right, so we talk about built-in functions, which is pretty useful. If it's already there, you might as well use it, right? Now, built-in functions are actually fairly limited, though. There are actually not too many built-in functions, at least in the very start. You can actually get even more functions in. You can get way more functionality by importing something called modules. So one way to think about modules are basically a library of code that's provided for you. It actually many of them already comes with the Python built in. It's just that the functions are not in the namespace. It's not in the coding space to begin with. It's just a separate step you have to take to be able to import the name and start using it. And they do that just so your space is not cluttered by a whole bunch of names. Right? You don't want to accidentally know that maybe my function at 1, 2, 3 is already defined, right? Like you actually want to have a separate step by which you import those functions or import those values into your space to start using it. So this is like one step extra you have to take. But the one step extra is pretty straightforward. So here, let's actually try to implement use a function for square root. Notice that we haven't used square root yet. And while you can actually implement your own square root for those of you who know how to do that, it's actually not that simple. Like implementing your own square root is pretty difficult. And not only that, if you probably implement it directly in Python, it's going to be heavily inefficient, right? So that's why Python comes with it. Any good package ought to come with something like square root, or maybe cosine, for example. Cosine, sine, you don't want to implement your own. You want someone to have already spent all the time to make it the most efficient implementation. You just want to use it. So in Python, you can get cosine, sine, and square root in these like typical mathematical functions not available yet. So for example, if I haven't imported anything, if I do square root or anything along the line, nothing comes up. Okay? But if you import a module called math, just like this, I just imported the math module. Now this math module exists, and underneath it, there are a bunch of math-related functions you can start to use. One of them being square root. So I can use it just like math.square root, like this. Right? And there's also math.sine for some, sine, cosine, the tangential ones, or trigonometrical functions. And you can look at the documentation on it. It says it returns the sine of x. Here it says measure in radians, so that's pretty helpful. So if it's measure in radians, the most convenient way is to use pi, right? If none of this sounds, familiar anymore, because I'm pretty sure at some point in your life you've encountered this. If you don't quite remember it, that's fine, just follow along. But you probably should know what sine is. So math.pi is the pi, right? Obviously a 3.145 kind of thing. It gives you this value so you can use it in dealing with anything that's trigonometric. So if you look at it, this is like some value. Obviously it's not perfect, right? I mean, pi goes much longer than that. Pi in fact goes on forever, right? It's an irrational number. You can never fully express it. So it truncates it somewhere. It has to fit somehow in the memory. So it truncates it. So this is obviously not going to be perfect. But we already talked about the fact that anything you do in computers is not going to be ever quite perfect, right? It's always up to some numerical imprecision involved. Anyway, this looks good enough because if you leave it up to me, I probably would have said 3.14. So it's far better than that. So using pi, I know, and this is just a check, pi half. So if I take sine of pi half, that ought to be, does anyone actually remember what sine of pi half is? 0, 1, 1, good. Okay, so these let you combine, right? Now, if you just want to use a specific function, rather than importing the whole module and just using the function underneath the module, you can actually just import the function directly. So you can say from math, the module, import square root. And now you can just use square root as is without having to say math.square root. Okay, so this is module. This is called module. It's just like a collection of functions and values that someone else has provided for you. In this case, Python. Python came with it. Yes?
So how do we know about modules? Where to find them?
Perfect question. You go look up the Python documentation. Yes, that's answer number one. How do you know all the list of modules? Answer number two, and probably the recommended, is you read someone else's code that looks relevant and learn from what the module they use. Like quite honestly, that's probably the better way to approach this, because if you go, say, visit Python, we can kind of slow it. You can actually get all the module documentations. It's probably like, where's the listing? Build and modules. Yeah, there it goes. So if you go, so these are the listing of all the modules that Python comes with. And this is just the one that comes with Python. And soon we'll be dealing with extra modules that someone else has implemented outside of the Python that we install and use, right? But just within Python itself, it comes with all these modules. And I mean, quite honestly, I probably know like maybe 5% of this, maybe 10%. I don't know. Well, so good to know where you can look it up, right? But oftentimes, if you start to work in a domain, the first thing you do is look for existing code, right? And if you look for existing code, then someone has to at least spend some time figuring out what module they might want to start with. And that's kind of how you start with a module. Like I really have never met a person who knows every module already, and that's how they start working on it. It's usually the other way around, where you start working on a problem, you kind of look for code, maybe you accidentally find a module that someone else used in some closely related issue, or after you get a bit more used to, you start to have a sense of, okay, is this already a module? That's going to become your first question, and you're going to start looking here, and maybe here I'm going to say, okay, maybe I want to do something with the path. Oh, okay, there's something that says it's about path name, so I'll start looking at the glob. That's how I usually work with this. Okay, so please don't try to learn all the modules. I mean, and you're more than welcome to, but I don't think that's a good practice. I mean, you're far better off doing something else than try just remembering this of all the modules. Okay, so with that, I do want to come to the point of coming up with your own module, and it sounds more difficult than what it actually is. So what I really mean by that is like, so all the functions we defined so far, let's say like the mean and totals and all the useful ones, at least the useful one like mean, say we want to reuse it later, right? But the problem is if it's defined here, it only exists here. If I create another notebook, it wouldn't be accessible from there. Now obviously I can copy and paste, but now you've created this like issue of code existing in 2 or more places. If there was a bug, now I have to fix it in both places. It kind of sucks. So modules are really there for you to like prevent the repetitive like typing of the same code. It lets you import the same thing so you can fix it once and applies everywhere. Okay, so with enough talking of that, let's just go ahead and create a module. The way you do is if you actually go to the top left here, there's a plus right there. That brings you to this launcher screen. So if you were to create a new notebook, you obviously would click on the notebook. This time instead, though, we're going to actually create a new file, the Python file. So we're going to actually click on the text editor. Okay? This creates a new file called untitled.txt. So the first thing we're going to do is we're going to go ahead and change the name. So if you click on right-click on it, you can rename this. Okay? And I'm going to call this my_module.py to indicate this is actually going to be a Python file. Save it. Now it's a Python file. You actually might, to make the syntax apply, let me actually just verify if it works. Okay, it's already in. So since it's .py, I already understand this is a Python code. So it will start highlighting code in Python with the appropriate coloring. Now let's actually go ahead and put something useful in it. So this is the point where you switching back and forth between tabs might be not that quick. But let's actually take this guy here, go over here, paste it in, just like that. So far, so good? Okay. Now you have successfully created a module. That's it. Now with this module, all you have to do is just import it. So let's go to where we were at. I don't know where we were at. I guess we were right around here. Yep. So good. I matched the name. So now if you run import my module, it should run fine, because it finds that locally in your file system, there is a file called my_module.py and understands when you say import my module, that's the module that you're talking about. And now, okay, I don't have count up, but let's actually say my module. And if you do dot and then plus tab, it lists the stuff that's available inside. One of them is just a file name, but one is the mean, which is the name of the function that's found inside that module, which is obviously the function you already implemented. So I can implement it like that, and it works. So this is the way by which you can actually take some piece of code that maybe you already tried it out in Notebook, verify it works, then once you're happy, you can put it in a module like this and just start importing from elsewhere. Right? So in fact, if you were to start yet another notebook, I could already import my module there as well, and this already functions. Okay, so this is how you can share code among notebooks easily and keep it in one place. So I know switching back and forth between tabs is not the fastest thing. Okay, so far so good. Okay, so with like 20 minutes or slightly less than 20 minutes left, I will attempt a very quick intro to object-oriented programming, and wherever I don't finish, I'll continue off with the next time. I want to leave last. Well, do you have to still put in the circle this time? Okay, I'll leave. And is there like a meeting right after this? Okay, so we did have to give 5 minutes at the end. Okay, so I'll give like last 5 minutes for cleaning up and like 2 minutes before that for homework explanation. Okay, so I'll try, and if you don't finish it, it's okay. We'll finish it off next time. Okay, so object-oriented programming. I don't know if you have heard this term before. If you look up any description about Python, many references suggest that Python is an object-oriented programming language or object-oriented scheme, or it has this particular word. Now, and if you start Googling for what object-oriented programming is, you're probably going to encounter stuff like encapsulation, polymorphisms, inheritances, and there'll be a lot of references to Java, C++, Ruby. There are many, many languages that use object-oriented programming, and they really like to be pretty complicated about how they explain what this is about. Now, that being said, it's actually not that difficult if you just take the essence of it, and if you don't dive into what computer scientists tend to like to dive into, which is more theoretical aspects of it. So this is my introduction to object-oriented programming without any of those theoretical and computer science terminologies involved. That's not to say that I'm not going to incorporate them. They will come up eventually in some sense or one way or another, but probably more through usage and not through explicit definition, because I believe more in use it and you get a sense of it, and then you can give name to it later, rather than me giving your name first and trying to understand what the name means. Okay, so motivation first. So say what I want to do now is I have a company X, right? In the company X, I have multiple people working in it, and I want to just track people inside, represent personnel of the company. And among the important information I want to keep track would be, say, the first name, last name, and the department they work in. So maybe there's this guy, John Doe, who works in the R&D, so research and development department. Okay, easy peasy. I can just put it in the tree variables. I got it. Okay, cool. And maybe I also write a function that takes in the first name, last name, and department and prints out a message or greeting, like introductory statement about that guy or the girl. So here I just define the greeting. I use the format to nicely format the string, and I apply the greeting on the tree variables I define. Okay, seems to work. No problem so far. What if, however, I start having multiple people I have to deal with, right? So there's not going to be only John Doe. There's going to be David K. There's Kaoru Suzuki, some random people I'm coming up with, and they all belong to different departments, and they all need to be represented. I want to keep track of all of them. You can imagine this cheap scheme where you have first name 1, last name 1, department 1, so on and so forth. And every time you print, you just have to make sure that you print the first name 1 with the last name 1 with department 1 and not accidentally mix and match. And you can still work with it. This sort of works. But it really gets clumsy, right? Now, one thing to also note is that this function greeting really doesn't really make sense outside the context of these three variables, right? It is really designed to work with the first name, last name, department as the way it's defined. And because it's so specific to company X, it's really specific for usages. It's not something like I would just take this function and give it to someone else, because they probably would not have any meaningful usage of this function. It's really tied down to these data. So whenever you have a situation where your function, or more than one function potentially, but function seems to be really strongly coupled to one or a couple of variables together, you actually want to be able to represent the fact that they're really tightly coupled and put it all together. And this is where the concept of object comes from, is ability to be able to put data with some functions together in one place. That's almost all there is to this. So the way you do, though, is by defining something called a class. So here I'm just going to go ahead and define the class, and we'll visit this a bit. So class definition starts with class keyword, and you define a class of an object, or a type of object that you're about to represent. Here I'm trying to represent personnel, or person. So I'm going to name this class a person. And inside there, this looks like a function definition, right? Starting with diff. Inside there I have two function definition. But since these are functions inside a class, these are called methods. And I'll get back to the big class again. And one of them is even special in that it starts with underscore underscore init underscore underscore. It's a special named method or function or method that will be used to initialize an object. And we'll get back to it very shortly. Anyway, so I just defined it. Greeting looks almost like what it is, except that it has this weird self parameter passed in. And when I'm printing stuff out, instead of printing first name, last name, department as this, I seem to be accessing the first name of self, last name of self, and depth of self. Okay, so loosely keeping in this mind, let's just go ahead and try to use it. what you can do is that once you define a class, you can create an object based on it. With this, or another way to say it is that you instantiate the class to create a particular object or an instance. Here I'm creating a new person1 by instantiating the person class. The syntax is person, the name of the class, open close parenthesis. This creates a person object. And person object has a couple of properties associated with it. In that, if you say person1.firstName, that is actually existent. It's not hard to see. If you say person1.tab, it actually lists different properties and method it actually comes with. So you notice it has first name, last name, and depth, as well as the greeting, which is the name of the method. And by default, if you look at the values, they don't give back anything. So notice that whenever a value doesn't seem to give back anything, that's indication is none, right? And that seems to, and that probably should kind of click in mind, this seems to be related to the fact that in the init, I say these three are none. So I'm initializing these values to be none. So these are properties used to describe the object. These are some properties that, that is about the object. Here the object is a person, so this is a description about the person. And the descriptions include first name, last name, and department, okay? Which is initialized to none at the moment. And they have a greeting method, which you can call. If you call it, notice that it says, hi, my name is non, and I work in non-department. Well, this is because it's reflecting the property this object has, which is currently all initialized to none. So let's give it more meaningful values by actually giving values to these properties. So I'm going to say first name is John, last name is Doe, department is R&D. And now if you call the greeting method again, this time it will correctly make use of those values. Well, it was already correctly using values, but now values makes more sense because they're not just none. And it will happily use it in the method. And now it says my name is John Doe and I work in R&D department at company X. Okay, so with this, let's go ahead and create two more personnel. We just instantiate another person, put the names, assign meaningful names and values to it. Do the same for the third person. And now we have person 1, person 2, person 3, three person objects. And for each of them, you can call the greeting method. And they'll correctly reflect the value for that object. Okay? So now we have some sense of what might be going on. Let's revisit the class definition. So this is the class definition. You say class person. There's an init method. This is the method that gets called at the very beginning. So when you instantiate, so like right here, when you instantiate, what it does is it creates a new instance, an object of that class, in this case person. And then in here, and that's what's represented by self. So self is a hidden keyword that gets passed around. You don't actually ever pass the self yourself. It just kind of gets passed around. And here, your job is to initialize it and give some properties. So here what I'm saying is that, well, self, this object will have a property called first name, last name, and department. And for the moment being, I'm initializing them all to none. Okay? And methods, other methods, more typical one like greeting, also receive this property called self, or parameter called self. And it's the same self. Basically, it's an object that you call this method on. And because the object will always have properties like first name, last name, department, you can make use of that in your function, just like it's doing here. Okay? So that's precisely what I just wrote here. We can actually improve this a bit. The init, by default, only takes self, but you can extend it by letting it take multiple arguments. And that will end up corresponding to arguments you can pass in when you initialize, when you instantiate the object. So maybe instead of just instantiating and later changing the name and department, at the time of instantiation, let's pass in the first name, last name, department, so it becomes one clean line. And then what you can do is just change init. So in addition to self, it takes in three more parameters: first name, last name, and depth. And you create the property and already assign what's passed in. So this initializes the object with the passed in names and departments. Okay, all in all, what this means is that now when you instantiate, you can pass in the three values already, like that. And here I'm actually just putting them in a list and then looping through to just print them all out. Okay, this feels probably a bit abstract, But hopefully you see that if you were to group values and functions together, this could also start to be a very convenient way to at least have them in one place, so you know that functions like greeting actually is about data that belongs in the same class, say person. So it makes sense together, right? Because otherwise, greeting on its own really may not make that much sense. It really expects certain kind of data to be associated. And those data also are completely associated with each other. First name of a person is associated or coupled to the last name of the same person, and you don't want to mix them all up, right? So this class object methodology allows you to group these things together in a compact fashion. So that's one way. Now, with this time, I'm not going to step through the more concrete example. What I've basically done is that, okay, instead of person, let's actually say you were to represent an eye tracker. And every eye tracker you work in behavioral apparatus has calibration. You have to like usually control the scaling of the X and scaling of the Y. So in some sense, every instance of an eye tracker requires its own value for scaling X, scale Y calibration parameters. So those becomes the property of that instance. It becomes the property of the class eye tracker. And you can have a function called convert or get screen location that if you pass in the eye position, it will give you the screen location according to the calibration parameter. So feel free to step through this on your own. It's pretty much the same exact way, but it's just based on a more concrete example of what you might actually do in the lab setting. And I guess the very last thing I was just going to say is like, in fact, everything in Python is an object. In fact, so the fact is like all the things in Python like lists and dictionaries are objects, and you can tell by the fact that they actually have methods. For example, lists, like lists and dictionary have methods like pop, remember? And even strings are actually objects because they have methods like lower, which returns the lowercase version of the string. It's a copy. Okay. And same thing with lists. Lists have like method called like something like index, which if you actually give a value, it searches for it and tells you where in the list you can find it. So this is just to say, despite the fact I didn't really say it, everything in Python is an object, and therefore they have properties and methods and behave the same way as if you were to define your object by defining your own class. Okay. So that's all I wanted to say. This implication becomes bigger later on in the class as we define more and more stuff, especially when we get to neural networks, which is session 7. So if you really get there, I'm really going to dive a bit deeper into objects because there everything revolves around the concept of objects and a bit of inheritance. Okay, so with that, let's just quickly talk about, I think I'm right on time, quickly talk about homework assignments. Starting from next week will be a different way of, I will be having a different way of giving homework assignments. Namely, I'll actually going to have you create a Git repositories and submit it online on GitHub and stuff like that. If you don't know what the hell I'm talking about, I'll explain it when it comes to it. For the time being, what I want you to do is take these homework assignments. So there are 4 challenges I've given you, plus 1, where 1 basically says take all the 4 challenges you've done and convert them into a function. Okay? The way I want you to submit it is this. Create a new notebook. Okay? Name it some way that's consistent with your name. So hopefully it will contain your first name and last name as something along the line of homework assignment. So so once you create the notebook, I want you to submit it into a public here. So if you go, you've been in work, right? So I can actually demonstrate how this could look like. If you create a new notebook, if I just call it something like Edgar Walker homework 1, right? You can actually, where did it go? Well, actually, can I do it here? I have to figure out. Oh, sorry, this one actually changed the interface. How do I put this back in home? There it goes. So if you do it, then you can move it into home, like one up, and then finally just drag it into your public directory. So just make sure that by Monday, if you could, put it in the homework, put it in the public directory, and that way I can see it. And one thing to note is that if it's in public directory, everyone else gets to see it. So I'm basically taking in on you that you don't cheat and look at each other because quite honestly, you're not great at. I really don't understand why you would look at other solution. You're not going to gain anything by doing that, okay? I mean, feel free to look once you solve it, sure, but get your solution first, make sure it works, put it in a notebook, put it in a public directory, and really, don't worry, this is not graded per se. I will look over it. Especially if you're officially signed up, I'll look at yours first. And as my time permits, I'll try to look at auditors. And I'll leave comments in the notebook itself. So once I say like, okay, everything's been graded, then you can go take a look at your own homework assignment and then take a look at, look at my comments and see what I said, see if you agree with it. And you can come back with complaints and stuff. Okay? All right, and one more thing is that please make sure that you've tried the local installation of your Python on your setup, right? So follow the instructions, make sure you have Anaconda distribution working on your computer by Tuesday. If you have any issues with it, let me know. I'll be more than happy to set up time to meet with you and work through your issues if that's what it takes. And also I've added this like last bit of Git installation on your computer. Stelios pointed out that I wasn't descriptive enough and that there are some options that I probably should have given you a bit more description of which ones to pick when you're doing the installation. So I'll try to follow up with that over in like today or tomorrow. So if you already install it, chances are it's probably okay. But if you really want, you can also redo the process to make sure you are selecting all the criteria that I recommend when you install Git on your machine. Okay? All right, that's all I have for today.